Okay. So, yeah. So, let's redraw our composition. So, the whole milk contains um, 4.5% fat, and based from our computation, our total mass of this whole milk is 104.6 kilogram. Okay, then we process it to remove this is our whole milk. So we remove fat that is about 4.6 kilogram, and I mean to come up with the skim milk that has fat content of 1% or 0.1 kilogram, and so on. Okay, so all in all, this, okay, let me rewrite it na nga. So we have 90.5 kilogram water, 3.5 kilogram protein, 5.1 kilogram carbohydrates, and 0.8 kilogram ash. Alright. Okay. So, okay, so from here, our skim milk, 0.1, our fat that is being removed is 4.6. So, by using the balance, our initial fat here must be, this component here must be 4.6 plus 1 is 4.7 kilogram, right? So this part here of fat must balance to 4.7 kilogram. Okay, if we've checked this, then we can now have let's check if we will come out with a 4.5% fat. Okay, so did you get it? So we have fat here from our skim milk, which is 0.1 kilogram, and our fat is 4.6 kilogram, a total of 4.7 kilogram for the fat. Okay, so therefore our initial fat, this part here, is 4.7 kilogram or 4.5%. Okay, if we've checked it using our total mass, then our solution here is that percent fat is equal to the fat mass divide the total mass of this whole milk total, times 100%, of course. So we have our fat is 4.7 kilogram divide 104.6 kilogram times 100%. Percent fat is 4.493 or around 4.5%, right? Okay, so that is the composition of fat. Okay, but our um, uh, our main task is to determine the other composition, right? Okay, so let's continue. We've already checked that initially the whole milk contains 4.5% fat, right? Because of this part here. Okay, but our main task is to determine the composition or the percentage of these other components or constituents of our milk. Okay, so we've already done with the fat, so let's move now to the water. So this water here is about 90 water is 90.5 kilogram, right? So our percent water is equal to the mass of water divided by the total mass of whole milk, wherein it is equal to our water is 90.5 kilogram divide our total mass is 104.6 kilogram. Okay, so about um, this is about 86.5%. Okay, so our water is 86.5%. Okay. Okay. So for the protein, so this part now here is our protein. Our protein is 3.5 kilograms. So we have percent protein is equal to the protein content divided the total mass of whole milk again. And our protein is 3.5 kilogram all over 104.6 kilogram times 100. This is equal to our protein is 3.3%. So our protein 3.3% protein. Okay. Then for the carbohydrate, this part here is 5.1 kilogram. Okay. So for the percent carbo, we have 5.1 kilogram divide 104.6 times 100 is equal to carbohydrate is about 4.9%. So we have 4.9% carbohydrate. Yan. And lastly, for the ash content, we have here 0.8 kilogram ash. So percent ash is equal to 0.8 kilogram divide the total, which is 0.45. So ash content is about wait 0.8 divide 104.5 times 100. Okay, so this is about 0.766 or about 0.8%. Okay, so this is about 0.8%. Okay, so all in all, the whole milk contains this percentage 4.5 plus 6. Okay. Okay. So this whole milk contains 4.5% fat 86.5 water, 3.3% protein, 4.9% carbohydrate, and 0.8% ash. Okay. So once again, this initial composition of whole milk, if we process it and remove from a total of 104.6 kilogram, if we remove 4.5 kilogram of fat, we can now have this composition of skimmed milk, which is about 0.1 kilogram, or one only contains 0.1% fat, 90.5% water, and so on. Okay, so that's all for the uh, our example regarding the total mass and composition using the mass balance or the material balance. Okay, so thank you so much, and see you on our next video.